Thank you very much, and thank you for the invitation. It's great to head up to Scotland. I always love coming up here. So you'll see that the slides are branded not with my University of Leeds, but with CREDS, which is now the largest research centre on energy demand solutions in the UK. It involves a lot of universities, and I'm a co-director of that centre. And it recognises very much that we need to drastically reduce energy demand extremely quickly to meet and respond appropriately to the climate crisis. I'm going to show some of the results from the Scottish carbon footprint today, and then also show the link between resource consumption strategies and policies and how effective it can be to help us meet climate targets, and then propose policy options on the way to sort of potentially address these issues. We provide this annually to the Scottish Government. We also do to DEFRA as well, and also other countries as well, which we provide the consumption-based accounts. Obviously, the way that it's calculated in Scotland, the way that everyone has to calculate it and report to the United Nations on is from a territorial perspective, and that shows our greenhouse gas emissions that occur inside the country. And Scotland is very successfully reducing these emissions, going down on average by 2.4% a year. You then notice that we calculate and provide the consumption-based emissions, and that includes all the emissions embodied in every item of expenditure by Scottish households. And so therefore those emissions could occur both inside and outside Scotland. And those have marginally declined over this nearly 20-year time series, reducing in essence by about 0.8% a year. So we have reduced our territorial emissions considerably faster than our consumption-based emissions. This isn't surprising. We have less control over our consumption-based emissions. We have less control over global trade, over supply chains. But at the same time, I'm going to show you how resource efficiency policy both can reduce emissions inside Scotland, but also have the benefit of reducing emissions elsewhere. I don't want to come up with an immediate target for you, but if we look at lots of the literature internationally about the scale of reduction needed to get emissions down to net zero and be consistent with the international goal of reducing emissions to 1.5 degrees, analysis shows roughly 8 to 10% annual reduction in emissions. I wasn't going to argue about whether it should be 8 or 10, but it's in that region. And so therefore, historically, territorial emissions reduction levels need to increase by a factor about 4-fold and a factor by about 12-fold for consumption-based emissions to be in line with global targets of 1.5. So in essence, I think we're all fully aware of the scale of the challenge to actually reduce emissions at that level. One other thing is this shows the emissions associated with Scotland's consumption footprint and whether they occur inside the UK, or inside Scotland, sorry, and outside Scotland. And now the emissions associated with consumption are higher outside Scotland than they are inside Scotland. And that's partly because more reduction has been achieved inside Scotland, so therefore the imports now have a higher impact than all the emissions associated with consumption that occur inside Scotland. I just picked out a few key products to show whether the emissions occur inside or outside, and so whether strategies to reduce your emissions, if you're going to look at production, are effective or not. So, for example, if you were to purely concentrate on the efficiency of industry, you're affecting Scotland's industry. You're not necessarily affecting the industries which supply Scotland with all the resources and all the materials and products it needs to satisfy consumption. However, the value of a resource efficiency strategy is that you are affecting it at the product level, and therefore it can be more effective at reducing emissions than efficiency inside the country. So for example, if we were to improve production of cement, for example, we would affect the emissions obviously inside Scotland. If we are to change our construction techniques so that we need less cement, we potentially are getting greater emission reduction both inside Scotland and outside Scotland. And because of the accounting system, where we generally only roughly care about our territorial emissions, the accounting system then in essence puts a greater perspective on emission reductions which occur in Scotland. and potentially ignores issues due to the accounting system which could actually deliver greater reduction. And therefore, while I'm not saying that you should change systems, I think they're complementary. When we're accounting and actually thinking about how we can contribute to climate change, a full accounting system gives us insights into mitigation options which are considerably more effective. And for some areas or product groups, that's really important. So if you look at construction, for example, a reasonable amount occurs outside of the UK, so outside of Scotland, so about 45% occurs outside of Scotland. So therefore, for you to actually address the embodied emissions and the way buildings are built and the level of infrastructure in Scotland has a greater effect on its impacts. If you were to think about cars, and this is the manufacturing of cars, not the driving of cars, but we're now not far off where the manufacturing of the car will have a greater impact than the actual driving of the car. So therefore, the absolute number of vehicles which are sold becomes a crucial part of the decision about how to respond to climate change, and also becomes a key resource efficiency issue. It's not about whether you're recycling those cars or not, it's about how many cars are sold on an annual basis and the embodied energy associated with them. So we undertook an analysis, and this is at the UK level. We've never taken this analysis at the Scottish level, but that could be done. But I still think the findings are extremely relevant. So this analysis helped form DEFRA's resources and waste strategy, where we took 44 different resource efficiency strategies. We found hundreds and hundreds of case studies and analysed their potential impact on reducing greenhouse gas emissions through resource efficiency. About 10 of them were recycling based, the other 30-ish were in essence trying to affect the way we consume. So an example might be using products for longer as opposed to just trying to recycle them. Of all those particular commodities, one thing we found that if we implement all of these strategies, then a resource efficiency strategy and the potential of it could be greater than a considerable number of climate strategies and policies already put in place. But I think a problem that we find with sort of Westminster government is that DEFRA do resource efficiency, BEIS do climate change, and never shall the two meet. And therefore, resource efficiency is not seen as a climate change agenda. But in reality, resource efficiency in itself is a goal to achieve certain environmental goals and reduce environmental pressures. So I think we demonstrated that resource efficiency strategy could be extremely effective climate policy. And we actually showed that it could actually bridge the gap and help the UK meet its legally binding targets if we were to implement it at a fairly adventurous level. And I can send the paper and all the information on the individual 44 strategies and their effectiveness, but I was given 10 to 15 minutes. But in reality, just a few things to pick out. One was we looked at actually the substitution of materials in construction. We looked at policies which would mean that you wouldn't be allowed to knock down a building, you'd have to refurbish it. A considerable amount of the embodied energy is in its foundation and the steel structure of the building, and that can be maintained, and so on and so on. All the policies we put in place exist already. So this was our kind of conservative estimate. This is not even assuming that we would unlock new innovation and ideas by starting on the path of resource efficiency. As I mentioned, lots of them are not recycling based, and that doesn't mean that I don't like recycling, but I'll come to that in a second. I just want to show one other quick point which might seem a little left field, but I think it's really important when I draw my conclusions in a second. We also did an analysis of the whole UK economy over the last 40 years to try and determine the role that energy efficiency, and we need to do this for resource efficiency as well, the role that energy efficiency has had in driving economic growth inside the UK. For the economists in here, when you look at the factors of production, people believe that it's labour productivity that's often unlocked huge economic growth. That isn't actually correct. We've demonstrated that energy efficiency improvements in the economy have driven more growth than labour productivity. And it also has the added value that there isn't a win-lose situation, because labour productivity hasn't necessarily always delivered. In essence, it means less jobs per pound, so in essence, in that respect, is not always a good thing. In reality, energy efficiency has basically contributed 25% of economic growth in the whole of the UK over the last 40 years. It's a huge driver of growth. The slight problem with that is that that in itself has increased energy demand, and therefore it's not an anti-efficiency agenda, but it's recognising that efficiency alone will not deliver our target. So I put those two pieces of evidence together just so I can draw these conclusions. One thing that came out very strongly was, of course we should recycle, and of course industry should use resources in a circular fashion to try and ensure that we get maximum social and economic value out of each tonne of material, each tonne of carbon, and so on. But it is almost impossible to recycle at a level which will have an absolute reduction in total material and energy use. It will simply not work without affecting and currently reducing levels of consumption. And the same goes for energy. Energy efficiency improvements alone, again, will have so many effects on increasing the size of the economy that will not affect the level of consumption. And so therefore, we suggest that an energy resource efficiency strategy must start looking at the absolute levels of material demand and absolute levels of energy demand, and it's a strategy to reduce that. And that this is far more important than long-term unproven technologies. I'm sure I don't need to teach people this, but we know that carbon emissions are cumulative, so the more we do now, the more difficult it becomes later. So therefore, short-term benefits or short-term reductions are worth considerably more than long-term options. And so taking that into account, one thing that that's very important, and we're now doing this analysis for the Committee on Climate Change, is that any policy on resource or energy efficiency, energy demand, must look at three options. And we classify these along with how it's classified by the Intergovernmental Panel on Climate Change, which is on avoid, shift and improve. Of course we should improve and become more efficient, but that alone will not do it. We need the shift in the way we consume, shift in business models, but we also need to avoid. We need an active strategy to reduce passenger kilometres, an active strategy to reduce the resources that flow through the economy, absolute reductions in in food calorific intake, absolute reductions in demand. And if we don't have a strategy on the avoid side, the other two alone will not deliver that strategy. The other important thing to take account of, as well as those distributional impacts that could potentially happen in relation to these policies. And this shows the total energy footprint of someone in the UK based on their income, with the 10 highest percent income at this level and the lowest at this level. You'll see that low income groups, their energy demand is highly dependent on heating their home. That's where we place our policy costs at the moment, on home heating. We don't place our policy costs on the area where the highest 10% income consume the most, like aviation. So we basically are funding our climate policy by asking the poor to pay a greater proportion of the costs to account for wealthy incomes to carry on with lifestyles which are incredibly unsustainable. And I think we have to be honest and put that on the table. Aviation is a perfect example there, where over 50% of people simply don't fly each year. However, we place the policy costs all on these lower income groups. 95% of people in the world have never flown. It's a habit of a very small, select, wealthy group. Finally, just in terms of policy options and the way we move forward, our analysis shows that it is very difficult to find what we would call economy-wide measures which can simply put everything right, albeit a price on materials, a price on carbon. They simply don't get to the level of detail needed for individual sectors. So we believe that what's very important here is that each sector has an understanding of how energy demand and resource use will go down. And therefore, it's a starting by having specific level strategies. Construction, we need standards on embodied emissions within buildings as well as operational use within the buildings. And these can be introduced as voluntary standards and measures which, if the change is not happening, can move increasingly towards regulatory approaches. And while you need the framework and targets in place, we find that it's these individual strategies within these sectors which potentially would make the difference. So I'll stop talking now. Thank you very much. Yeah.